In the measurement unit, we're going to continue to look at three-dimensional figures, and we're going to be looking at composite figures. So we're not just looking at a cone or at a cube, but we're looking at a cone and a cube together. So in our first example, we have a cube-shaped box that has sides that are 10 centimeters in length. Inside is a solid cone. We want to find the dimensions of the cone and the surface area of the cone. So let's underline what we need to do. We need to find the dimensions. So dimensions are like length, width, height, radius, slant height, those sorts of things. And we need to find the surface area. And in both cases, this is involving just the cone. But we're only given information about the cube. So what we need to do is we need to start off by labeling the information that we've been given and then see how we can extract some information from our cone or for our cone from that. So if our the sides are all 10 centimeters in length, so let's label that. So we have a height of 10 centimeters, we have a width of 10 centimeters, and we have a length of 10 centimeters. So our cone just fits inside this cube. So let's draw on a height for our cone. Here's the height of our cone. So the height of your cone is going to be the same as the height of your cube. So h is equal to 10. And we can see that the circular base of our cone just fits inside the cube. So that means the diameter is going to be 10. And if the diameter is 10, then the radius is going to be 5. So r is equal to 5. So let's just write that down. So diameter is equal to 10 centimeters, and radius is equal to diameter divided by 2. Okay, so that's how we get our radius of 5 centimeters from there. So we have found the dimensions of the cone. So under dimensions, I'll put of cone to be more specific. So dimensions of cone, radius is equal to 5 centimeters, height is equal to 10 centimeters. Now we are asked to find the surface area of the cone. So for the surface area, let's write out our formula. So the surface area of the cone is equal to pi times radius squared plus pi times radius times the slant height. So we don't have the slant height of our cone just yet. So we're going to need to solve for that. And the slant height is this part right here. There's our slant height. So let's just label that. Let's see if I can squeeze it in here. Slant height. And you'll notice that here we have a right triangle. Let's draw on that little 90-degree box down there. So we're going to need to calculate our slant height before we can calculate the surface area. So I'm going to do that at the side over here. So to find the slant height, we need to use Pythagorean Theorem, which is c squared is equal to a squared plus b squared. And I'm going to redraw our triangle over here. So our triangle, let's see if I can squeeze it in the top here. There we go. There's our triangle. This is 10, and this is 5. Sorry, this is a little squishy here. And again, there's our slant height, which is noted by S. So here's Pythagorean Theorem. Now we need to fit these into this formula. So this is your hypotenuse, which is S. Okay, so now we have s squared, and then one of these is a, one of these is b. So s squared is going to be equal to 10 squared plus 5 squared. So s squared is then equal to 100 plus 25, and s squared is equal to 125. And we want to take the square root of each side to get s by itself, because we don't want s squared, we just want s. And that is going to give us approximately 11.2 centimeters. So we're always rounding to one decimal place unless we're told otherwise. So now we have our slant height. So we can now calculate our surface area because we have all the needed information. We have the radius is 5 and we have the slant height at 11.2 centimeters. So we're just going to plug all that information in here. I'm going to put this in a box here because the page has gotten a little squishy right now. I'm going to use 3.14 for pi. So you can use the full pi button if you wish, and you may get a slightly different answer than me. Okay, so I've put in all of our information for surface area, and now we're going to make sure we follow BEDMAS when we're doing the calculation. Many of you will have a calculator that will do it all for you, but in case you don't, we need to make sure we do the exponents first. Here, this is all multiplied together. This is going to give us 175.84, and 3.14 times 25 gives us 78.5. Okay, we add that together, and as we do, we want to round it to 1 decimal place, so that's going to give us 254.3 centimeters squared for our surface area. Okay, so here's our final answer.